Good day, students. You are welcome to your favorite YouTube channel, Physics for Everybody. Today we'll be solving your 2023 February-March Physics 0625 Paper 2, your IGCSE Physics. And this we'll be using the new curriculum which covers from the year 2023 to 2025. This is the curriculum where we discuss space physics for the first time. Okay, not for the first time in IGCSE though, but recently this is the first time we're touching space physics. So make sure you watch this video from beginning to end so you learn how to answer questions on that. Okay, let's go straight to question number 1. Which list contains two scalar quantities and two vector quantities? Distance is a scalar quantity, speed scalar, time scalar. All of these are scalar quantities. Only velocity is a vector quantity. So this is wrong. Number 2. Force is a vector quantity, velocity is a vector quantity, distance is a scalar quantity, mass is a scalar quantity. So we have two scalar quantities and we have two vector quantities. And that's the option that correctly answers the question. The rest of them, this is a vector quantity, this is a vector quantity, this is a vector quantity, this is a scalar quantity. And as for mass, scalar, 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 vector. So none of them satisfy the condition except that option. Question 2. The diagram shows the speed time graph of a car. The vertical axis is the speed, the horizontal axis is the time. Which road describes the motion of the car at point X and at point Y? What do you have at point X? At point X, we have what? We have acceleration. And this fact that this is a straight line shows that it is a constant, non-uniform acceleration. Okay? Or you say, yeah, and whenever we say something is accelerating, that means it's moving with changing speed. Okay, so this statement here is correct. Okay, here moving with constant speed is wrong. So C is correct for X. D is also correct for X. Okay, it's moving with changing speed. What about Y? You see that this flat line here, where Y is, it shows that this place has uniform speed or constant speed. The speed is not changing. So Y is uniform speed. A moving with constant speed. The A is correct for option Y, but it is wrong for X. So you won't pick A. B at rest, no, it's not at rest, it's moving with constant speed. So this is correct, okay, for Y, and this is also correct for X, okay, because X is moving with changing speed. So in that case, D is the correct answer to question number 2. So we shade D. Straight to question 3. 4 objects are moving in straight line. The table shows the distance moved by each object in each second of its motion. Which object is moving with constant non-zero acceleration? Look at object A. Distance moved in first second 5 meters. Distance moved in second 5 meters. So it keeps covering 5 meters at every 1 second interval. That means it is moving with constant speed or uniform speed. Okay. But the question says which object is moving with constant non-zero acceleration? As for A is constant speed, so it does not correctly answer the question. Let's look at B. Option B, distance moved in first second 5 meters. Distance moved in second 6 meters. Distance moved in third second 7 meters. So the distance moved in every 1 second interval keeps on increasing by a uniform amount. The distance moved keeps on increasing by a factor of 1. Okay, it keeps on increasing by a factor of 1. Yeah, the first second it covers 5 meters. The second it has covered 6 meters. The third second it covers 7 meters. So the fact that the distance keeps increasing by equal amount, that shows that it has uniform acceleration. Okay, or you say constant non-zero acceleration. That means option B is the only option that's correctly answered question 3. In the case of C, the acceleration is not uniform because the increment is not uniform. Here it is +2. 5 plus 2 gives us 7. You come to the next one. 7 plus what will give you 10. 7 plus 3 will give you 10. Okay, 10 plus 4 will give you 14. So it is not uniform in the third case. And in the fourth case, it's definitely not uniform because here you have +3, here you have +6, and here you have +12. Okay, that shows that the acceleration is high and is not uniform. So that acceleration is exponential. Question 4. The drag force on a car increases with its speed. At 20 meters per second, the total drag force is 400 Newton. Okay, so let's see. Drag force is 400 Newton. The mass of the car is 1,200 kilogram. So the mass is 1,200 kilogram. What else do we have here? And the driving force is constant at 400 Newton. The driving force is 700 Newton rather. The driving force is 700 Newton. Which statements about the acceleration of the car at 20 meters per second is correct? Okay, so you are interested in acceleration at 20 meters per second. How do you get acceleration? We use the expression resultant force is mass multiplied by acceleration. How do you get resultant force? We take the difference between the driving force and drag. You know, drag opposes the motion of the car. Let's assume this is the car and the driving force pushes it forward. The driving force has a magnitude of 700 Newton. While drag is caused by air resistance, drag tends to oppose the motion. Okay, that means we are opposing the motion of the car with a force of 400 Newton. Okay, opposing it, that's acting in an opposite direction to the direction in which the car is moving. So how do you get the resultant force now? We take the difference, 700 minus 400 will give us the resultant force. Okay, so the resultant force will be driving force minus drag. Sorry, the resultant force will be the driving force minus drag. Okay, that will be 400 minus 700 minus 400 rather, and that will give us 300 Newton. That's the resultant force. Now let's substitute this value. The resultant force is 300 Newton. So we have 300 is equal to the mass. We don't have the mass times. No, we have the mass. The mass is 1,200 kilogram. So it will be equal to 1,200 times acceleration. We don't know the acceleration. How do you find acceleration? We divide both sides by 1,200. So when we divide both sides by 1,200, what will you have? When you divide both sides by 1,200, sorry about that. So we have to divide both sides by 1,200 in order to ensure we have acceleration left. So when you divide both sides by 1,200, this will cancel out. We have our acceleration is equal to 0.25 meters per second square. That will be the acceleration. So according to the question, the acceleration is 0.25 meters per second, but will decrease as time passes. Of course, the acceleration will continue to decrease. Okay, why? Because drag will continue to oppose the motion of the car, and as drag continues, since drag continues to increase, therefore the resultant force will continue to reduce. Okay, because you are subtracting drag from the driving force. The driving force is constant, 400, but this drag continues to increase as speed increases. So as drag continues to increase, drag will continue to increase beyond 300, and as drag increases, then the resultant force will reduce. Once the resultant force reduces, okay, let's assume this one reduces to 250. By the time you divide 250 by 1,200, you get a value less than 0.25. So acceleration will continue to reduce till acceleration becomes zero, and then the car will continue to move with a constant velocity. If it was objects falling from the sky, then we consider those objects to be moving downwards with a terminal velocity. Okay, of course, that is not necessary here. We have answered the question. Let's go straight to question 6. Question number 6 says, a rectangular swimming pool is 50 meters long and 25 meters wide. It contains water at a depth of 2 meters. The density of water is 1,000 kilograms per meter cube. What is the mass of water in the swimming pool? How do you get the mass of water in the swimming pool? Do not forget that density is equal to mass divided by volume. So if you want to get mass, you say mass is equal to density multiplied by volume. Okay, so in this case, let's remember that density of water is 1,000 kilogram per meter cube, right? Good. And what's the volume? The volume will be the volume of the rectangular swimming pool, and that will be length times width times breadth or width times height. What's the length? The swimming pool is 50 meters long. Length is 50. The breadth is the width, which is 25, and then the height is the depth, which is 2. 50 times 25 times 2 gives us 2,500 meter cube. Now we substitute this value into the formula for calculating the mass, density times volume. So the mass is equal to the density, which is 1,000, multiplied by the volume, 2,500 meter cube. By the time you multiply these two, you get 2,500,000 kilogram, which is option D. That makes option D the correct answer to question 5. Question 6. Question 6 says, an object is rising vertically at constant speed through water. There are 3 vertical forces acting on it: the weight W and the drag force D and the upward force U. Which diagram shows the magnitude and the direction of the vertical forces acting on the object? Now, from the question, you were told that the object is rising vertically upwards. Is rising vertically. Rising vertically. That means it's moving upward. And do not forget that drag opposes the direction of motion. That simply means since it is rising upward with an upward force, okay, it has an upward force U. Since the upward force U is going upward, is in this direction, therefore drag will be in the opposite direction. Why? Because drag always opposes motion, okay? And do not forget that the weight of every object acts in one direction. Let's assume this is the object. Its weight will act downward. Weight always acts in the direction that goes downward, in opposite direction to the direction of sorry, in the towards the center of Earth. Yes, so it's towards the direction of the ground. So which diagram illustrates this? That's the diagram we have at D. Okay, upward force goes U, the downward force is both drag and the weight. And that is what we have here. And that makes option D the correct answer to question 6. We go straight to question 7. 2 boys of equal weight sit on one side of a seesaw. Their father, of weight 1,000 Newton, sits on the other side. The seesaw is balanced and is being used so that it moves up and down. During one part of the cycle, the father descends through a distance of 40 centimeters. At the same time, the boy nearest to the pivot rises through 20 centimeters, while the other boy rises through 80 centimeters. What is the weight of each boy? Now, the father creates an anti-clockwise moment, okay, while the boys create a clockwise moment. We do not have the weight of the boys, but the question says 2 boys of equal weight. So let us assume the weights of the boys are W and W, okay, while the weight of the man is let's call the weight of the man F1. Now, you know, the man sitting in this position is creating an anti-clockwise moment about this pivot, while those 2 boys are creating a clockwise moment about the pivot, right? Now, let us recognize the fact that each of the boy is creating clockwise moments, okay? Now, the father is creating clockwise, anti-clockwise moments, the boys are creating clockwise moments. And for a body to be in equilibrium, the total anti-clockwise moment, must be equal to the total clockwise moment. Now, the father is creating anti-clockwise moment, his weight, which is the force F1, his weight is 1,000 Newton, and his distance for the pivot is what? His distance from the pivot is he descends 40 centimeters, which is proportional to his distance from the pivot. Okay, so we just use is the 40 centimeter descent as his distance from the pivot, since they are proportional to each other. Okay, so the clockwise moment will be the weight of the first boy, W, which you do not know, times his distance from the pivot. The distance from of the first boy from the pivot is 20, plus the weight of the second boy, which is W, multiplied by his distance from the pivot. The distance of the second boy from the pivot is 80. So this is the expression that you will solve. Once you solve this equation, you get the value of W, okay? And that W will be the correct answer you are looking for. Now let's solve. 1000 multiplied by 40 will give us 40,000. 40,000 must be equal to W times 20 will give us 20W, plus W times 80 will give us 80W. Hence, we have 40,000 is equal to 100W, because 20W plus 80W will give us 100W. So let's finish our calculation here. So this is the same thing as saying 100W is equal to 40,000. If 100W equals 40,000, we can divide both sides by 100, so W stands alone. Okay, so now we have W is equal to 40,000 divided by 100, we get 400 Newton, and that's the weight of each boy. That makes option B the correct answer to question 7. Question 8. A student measures the length of a spring. She then attaches different weights to the spring. She measures the length of the spring for each weight. The table shows her result. Now this is her result. What is the extension of the spring when the force is when the weight of 3 Newton is attached to it? So the question asks us to do what? The question says, what is the extension of the spring with a weight of 3 Newton attached to it? So these are the weights. When the weight is 3 Newton, what will be the extension? Take note that as 3 Newton, the length was 533, and as 0 Newton, the length was 520 millimeter. 0 Newton means the original length when no force is applied. Okay, when the force was 0, the length was 520 millimeters. And when you are increasing the force, when the force is 3 Newton, let's call this our L1, okay, or we can call it our L3 if you want absolute distinction. Okay, so our L3, that's the length when the force was 3 Newton, is 533 millimeter. Now the question asks for the extension. How do you get the extension? Extension is the change in length. So in this case, our extension will be L3 minus the original length when the force was applied. That's all. Our L3 is 533 millimeter. Our original length is 520 millimeter. 533 minus 20, that will give us 13 millimeter, and that is the extension of the spring. And that makes option D the correct answer to question number 8. Question 9. The momentum of a body is changed by a force acting on it for a period of time. When action increases, which action increases the change in momentum? Option A, doubling the force and halving the time. Do not forget that momentum is the same thing as the momentum is the same thing as the impulse. Yeah, the momentum is the same thing as the impulse applied, which is force times time. Impulse is force times time. So the first option says doubling the force and halving the time. If you multiply this by 2 and then you multiply this by half, then you have not done anything different. You have just done the same thing. 2 times half is 1, so you've not done anything different. Option B, doubling the force for the same time. If you multiply the force by 2, then truly you have increased the momentum. That means option B, that's where we increase the momentum. Let's look at C, having both force and time. If you multiply this by half and multiply this by half, or you say divide this by 2, divide this by 2, then you have reduced the momentum by 4. Yeah, you have divided the momentum by 4. Option D, having the force and doubling the time. If you divide this by 2 and then multiply this by 2, then you've not done anything different, okay? Because half times 2 equal to 1, so you have not changed anything about it. So that makes option B the only correct answer. Number 10, the equation used to find the change in gravitational potential energy of an object can be written as follows. This is the formula for finding change in gravitational potential energy. And do not forget that the change in gravitational potential energy, the original formula is what? is mass times gravitational field strength, okay, mass times gravity times height, mgh. Now this says where delta E subscript P is the change in gravitational energy and delta H is change in height. So we have our change in height, okay. Okay, you can also refer to this H here as the change in height, okay. You can decide to represent it with this symbol delta H, meaning the change in height, okay. Good, so let's continue. Which role gives the quantities y and z? You know, delta H is our change in height. Automatically, y and z remain our mass and gravity. That's all. So option A, mass, gravitational field strength. A is correct. Okay, if you say gravitational field strength density, of course, there's no density in the formula for gravitational potential energy. There's nothing like speed. So only A is correct. A machine, number 11, a machine has a power input of 200 watts. Okay, so power input is 200 watts. Let me write that correctly. Okay, good. So let me zoom in so I can write correctly. Now, the machine has a power input of 200 watts. And what will be the output power? Anyway, the question says and a useful output energy of 1 kilojoule in 6 minutes. And do not forget that the formula for power is change in energy per unit time. Power is the rate of dissipation of energy, okay? Our energy is 1 kilojoule. 1 kilojoule is 1000 joules, right? Good. And 6 minutes will be 6 times 60 seconds. We have to convert this 6 minutes to seconds. Okay, that's why I multiplied the 6 by 60. Okay, so that's how I got my time in second. So if I divide 1000 by 6 times 60 gives us 3600. So I'll divide 1000 by 3600 and see what I'll get. 1000 divided by 6600, no, divided by 6 times 60, that will be 3600. No, 360, not 3600, 360. Yeah, 6 times 60 is 360. That will give us 2.78. Yeah, so we have 2.78 as the power. 2.78 watts. That will be power output. Okay, power output. Now, the formula for efficiency is power output divided by power input times 100%. So let's put that here. Our power output is 2.78. We divide it by our power input. What's our power input? That's 200 watts given to us in the question. Then you divide it by 200 and then you multiply it by 100 to express it in percentage. So 2.78 times 100 divided by 200. If you do this, you should get 2.78. Let's approximate this to be 2.8. So 2.8 divided by 200 times 100, that will give us 1.4%. So you can confirm this with your calculator. That means 1.4 the correct answer, option C. Question 12. What is the unit of power? Power is measured in watts. This is the correct answer. Question 13. The diagram shows a rectangular block of weight 6 Newton. It is resting on a flat surface. It is resting on this flat surface. What is the pressure at the base of the block due to its weight? Do not forget that this is the base, okay? This part is the base. And since this is 4 centimeters, it means from here to here is also 4 centimeters. And since this part is 5 centimeters, it also means from here to here is 5 centimeters. Now, how do you get the area of this part of this shape? We do length times breadth because this shape is a rectangle. So the cross-sectional area of the base is length times breadth. Our length is 4, our breadth is 5. That means the area is 20 cm square. But the question requests for the pressure at the base, not the area. What is the formula for pressure? Pressure is force per unit area. Force divided by area. What's the force? The force is the same thing as the weight. Okay, the force is the weight. Okay, while the area is the cross-sectional area we have just calculated. Now let us solve. Pressure is the work, is the weight. Okay, pressure is force over area. The force is the weight. Okay, and the area is what? The area is 20 cm squared. So 16 divided by 20 will give us 0.8 Newton per centimeter squared. That makes option C the correct answer to question 13. Let's go to question 14. An oil tank has a base of area 2.5 meters square and it's filled with oil to a depth of 1.2 meter. The density of oil is 800 kilogram per meter cube. What is the force exerted on the base of the tank due to this oil? Do not forget that the formula for pressure in liquid is density times gravity times height. So without work, do we have the height? We have gravity. Okay, so we want to get the force. Is that going to work? What if we decide to find the volume and then we get the mass? Then we multiply mass by gravity. Yes, that's going to work. An oil tank has a base. We have the base area and we have the depth. How do you get volume? Volume is cross-sectional area multiplied by height. Yes, if you were to calculate the volume of this cube, this cuboid here, we multiply this base area by this height of 9 cm. That will give us the volume of this cuboid. So in this case, we multiply area by height, we get the volume. The area is 2.5 meters squared. The height is 1.2. If you multiply 2.5 by 1.2, you get 2.5 multiplied by 2. That will give us 5. That will be 2.5 plus 0.5. That will be 3. That will be 3 meter cube. That's the volume. The volume is 3 meter cube. And yes, so since density is equal to mass divided by volume, if you want to get mass, you say mass is density multiplied by volume. So we multiply our density by our volume. The density of the oil is 800 kilogram per meter cube. So you multiply 800 by our volume is 3 meter cube. Multiply 800 by 3, you get 2,400 kilogram. Now the question requests for the force, not the mass. How do you get force from the mass? The force in this case is equal to the weight of the object. Yes, weight is the force on an object due to gravity, and weight is mass times gravitational field strength on the earth. You know gravitational field strength on the earth is 10, and we already have our mass as 2,400. So you multiply our mass of 2,400 by gravitational field strength, which is 10. 2,400 multiplied by 10, that will give us 24,000 Newton. That makes option D the correct answer to question number 14. We go straight to question 15. Question 15 says, a sample of glass in a rigid container is trapped in a rigid container, sorry. As the temperature of the gas is increased, the pressure is increased. Which statement is not correct? A. Gas molecules have greater kinetic energy. Yes, if pressure is increasing, it also means the kinetic energy of the particles. So if temperature is increasing, it also means kinetic energy is increasing because temperature is related to the average kinetic energy of molecules. B. Gas molecules hit the walls of the container harder. Well, since pressure is increasing, that means the molecules hit the container more frequently. C. Gas molecules hit the walls of the container more frequently. Yes, that's correct. They hit the container harder because they have more kinetic energy. They also hit the container more frequently. Option D. Gas molecules move further apart. That is not correct because so that makes us the correct answer. Okay, because the question says which one is not correct. This is the one that is not correct. Why? Because if it was solid molecules, you know, solid molecules are fixed position. So if you apply heat to solid molecules, what will you have? You have something like this. You have the solid molecules looking like this. What does this mean? It means the distance between the molecules has increased as a result of heat. Why? Because the molecules are not free to move about. They can only vibrate about their fixed position. But in the case of gas molecules are always moving. Okay, this one will move, this one will move in any direction. They're always moving in random direction. Okay, so you cannot say the average distance between the molecule will increase because the molecules are constantly moving and you cannot predict what the distance apart would be. Good, so this is not correct. Number 16. What happens when the temperature of a liquid increases? Option A says the mass of the liquid increases. No, temperature changing has no effect with mass. That makes B also wrong. Okay, mass increases. No. Volume of the liquid increases. Yes, increase in temperature causes expansion, making the liquid less dense. That's correct. Okay, when something expands, its density reduces. Question 17. A bar of metal, which is a good thermal conductor, is heated at one end. What is the main method of transfer of thermal energy along the bar? You know, in solids, heat transfer is by conduction. And since it's a metal, metals have free electron. So it is the free electrons that will help to transfer the electrons. And do not forget that in the case of conduction, the molecules vibrate. Okay, the molecules move to and fro. Yeah, molecules move to and fro, hitting each other and transferring energy from one molecule to another. And what are those molecules or those particles that move in this case? They are electrons. Transfer of electrons. Electrons help to transfer thermal energy in metals. Okay, if it is a metal, then it is with electron. But if it's not a metal, then it can be the vibration of the particles or the molecules. Number 18, a transverse wave moves along a rope. The diagram shows the position of the rope in one particular time. So this is the rope. Which two label points are one wavelength apart? Of course, it is from here like this. This is one wavelength because this is the only place whereby you show you have one full cycle that are labeled. Of course, in this case too, let me use another color. This is also a full wavelength, but this point here is not labeled and is not among the option. So the only option you can pick here is from X to Z, and that is option C. That makes option C the correct answer to question 18. We move straight to question 19. Light is light in transparent plastic meets the boundary with air. Light is transmitted into air only if the angle marked theta in the diagram is greater than 36 degrees. That simply means 36 degree is the critical angle. That means our critical angle is 36 degree. Okay, the question now asks us, what is the refractive index of plastic? Refractive index is 1 over sin critical angle. Okay, so you do 1 over sin 36 degrees. So let's do 1 over sin 36 and see what we get. Let's go. 1 over sin 36. 1 divided by sin 36 degrees, 1.7. So that should be the correct answer, 1.7, option D. Question 20 says, where where is the image, sorry, a thin convergent lens has focal length f. An object O is placed to the left of the lens as shown. So we have the object placed at the left side of the lens. Where is the image formed and how does its size compare to the object? Since distance from here to here is one focal length and the object is closer to the length than the focal length, that means the image will be formed at the same type of position. Okay, the image will be upright, it will be virtual and magnified. So opposite direction, no. Opposite position, no. In the same side as the lens, yes. Larger than the object, correct. That's what we mean by magnified. It will be formed in the same position and it will be bigger than the object. We go straight to question 21. Which diagram shows what happens when a ray of white light passes through a prism? Let's see. So if white light passes through a prism, there will be dispersion here. So this is not correct. So the second case, option B, it's when white light passes, there will be dispersion. The change in direction from here to here is incorrect. When it passes, it should be deflected this way, not this way, not further away from the normal. So this is not correct. Option C, this is correct, this is correct. But when it's coming out here, it should be yeah, when it's coming out here, there should be dispersion, and the angle of refraction will be away from the normal in this direction, not this way. So this is not correct. This is the only ray diagram that is correctly drawn that represent the situation. Question 22. A TV station transmits a signal to a television receiving dish. The television has an on-off indicator light. Okay, so this is the on-off indicator light. This is the television. The television is switched on by a remote control which changes the indicator light from red to green. This is the remote control. It changes the light from red to green. This is the television station, okay? The television station and receiving dish. This is the receiving dish of the television. So the television station sends signal. It sends microwave to the satellite, and then the satellite transmits the signal to this dish. The radio wave received by the dish will be sent through the antenna to they will be connecting wires to the television, okay? And then the remote control will be using infrared rays to change the color of the light here, and the light here is visible light. The question says, which electromagnetic wave used in this action has the longest wavelength? You know, radio waves have the highest wavelength. Yeah. According to electromagnetic spectrum, we have radio waves, we have microwaves, we have infrared, visible light, ultraviolet, X-ray, and gamma rays. Radio wave has the longest wavelength. Question 23. A student makes a list of some application of waves. We have medical scanning of soft tissue, sterilizing water, using sonar to calculate ocean depth. Which application use ultrasound? Okay, we can use ultrasound in this case. Whenever you hear sonar, we're talking about sound with high frequency. Also, in this case, ultrasound to scan soft tissues. Okay, yeah, you can use ultrasound to scan soft tissue. And if you want to scan bone, then we use X-rays. For sterilizing water, we use ultraviolet rays. So only 1 and 3 satisfy that condition, which is option C. Only 1 and 3 satisfy the condition, which is option C. Question 24. Question 24 says, the diagram shows a bar magnet at rest on a smooth horizontal surface. A length of soft iron wire is held parallel to the magnet. This is the magnet, this is the wire. The wire is released. What happens? Since this is iron, the magnet will attract the iron, and that's all. The wire moves away from magnet, no? The wire moves towards the magnet. Correct. D is the correct answer. Okay? The magnet will attract the iron. That's all. Which diagram shows electric field pattern and direction around positive point charges? This is a positive point charges. Why? Because the line of force, they all radiate outward. Okay? From here, it radiates outward. But in the negative charge, they are radiating inward. Okay? From here, it goes inward. From here, it goes inward. You see the direction of the arrow pointing inward. That means this is a negative, while this is a positive charge. As for these two, they are conducting wires. Question 26. A laboratory has a standard wire of known resistance. It also has other wires made from the same material as the standard wire, but of different length and diameter. Which wire would definitely have a resistance of less than the standard resistance of the standard wire rather? So in order to increase the resistance of a wire, you have to make sure the diameter is very small, okay, and you also make sure the length of the wire is very high. That means the wire must be very long. That will make it to have high resistance. But if the wire is thick, okay, and then it's short, then the resistance will be very small. Why? Because resistance of a material is resistivity multiplied by length divided by the cross-sectional area. Okay, so resistance is directly proportional to length and inversely proportional to area. So when area is large, resistance will be small. When length is large, resistance will be big. So the one that will have less resistance is the shorter and larger wire. That makes option C the correct answer to question 26. Question 27. The graph shows the relationship between current in the circuit component and the potential difference across it. The graph has a straight section and a curved section. What happens to the resistance of the components in these two sections as the current increases? So as the current increases, what happens? A, resistance increases. Yes. Why? Because from Ohm's law that says V equal to I R, that means I equals to V over R. Yes, yes, yes. So if current is increasing, then resistance will be increasing. That's why the curve looks like this, and it wants to be pegged at this value. That means if current is increasing, then the resistance will definitely be increasing. Okay. Um, so the straight section, what does it show? Does it show that resistance is increasing? No, resistance is not increasing here. It's because of this curve path that we say resistance is increasing as current is increasing. But in the straight section, Ohm's law will be obeyed. Okay. So in the straight section, resistance is increasing. That's not correct. And resistance increasing, no change in resistance, yes. While in the curve section, resistance is decreasing, no, resistance is increasing in the curve section. While in the straight section, no change in resistance. D is the correct answer to question 27. 28, the diagram shows part of a circuit. What is the combined resistance of the resistors? Okay, so this parallel combination of resistor, okay, these two are in parallel, but do not forget that before this parallel combination, these two are in series, so we have to find the series resistance here. We add them together, 2 plus 1 equal to 3. So now we have 3 ohm resistor in parallel with 4 ohm resistor. The formula for the equivalent resistance will be R1 R2 divided by R1 plus R2. That's the formula. Let's take R1 as the 3 ohm resistor. We still have 3 times 4. Let the R2 be 4 divided by 3 plus 4. 3 times 4 is 12. 3 plus 4 is 7. 12 divided by 7 will give us 1.7 ohms. That makes option C the correct answer to question 28. 29. The diagram shows a circuit which includes 2 resistors and a battery. We have 2 resistors here, we have a battery here. The voltmeter reads 6 volts. Okay. What is the potential difference that causes the 30 ohm resistor according to voltage divider? If there is 6 volts here and the resistance here is thrice this value, therefore the voltage here will be thrice the voltage here. Okay, so you multiply this 6 by 3. That's just the shortcut. 6 times 3 gives us 18. 18 ohms is the correct answer. We conserve time. Question 30. A wire is moved down in a direction perpendicular to the magnetic field. So magnetic field runs from north pole of a magnet to south pole of the magnet. So let's just try to make the field uniform, okay, by drawing parallel lines. Okay, now the wire is moved downward in a direction perpendicular to the field. What happened? 3 changes are suggested. The speed of movement of the wire is increased. The magnetic field strength is decreased. The direction of the magnetic field is reversed. Which changes increases the electromotive force EMF induced in the wire? Number A, 1 and 3. Okay, how do you get the force? According to the relationship, F is equals to B I L. That means in order to increase the force, you have to increase the magnetic field strength, increase the current, increase the length of the wire. Probably that will be possible by increasing the number of turns. As you are increasing the number of turns, you are increasing the length of the wire. So these are the 3 things you can do in order to increase the force. Okay. So let's see. The speed of movement of the wire is increased. In order to increase the speed, okay. So which change increases electromotive force EMF induced? Okay, so electromotive force also F is equal to BQ V. Yes, yes, yes. F is equals to BQV. So in order to increase the electromotive force, yes, you just have to increase the number of turns or you increase the current. That will also increase the voltage. Yes, electromotive force is the voltage. So let's see. Um, Increasing the speed of movement. Yes, yes. If you increase the velocity, it will increase the electromotive force. Also, decreasing magnetic field strength will not increase the electromotive force. The direction has nothing to do with this. Direction has no business with this. Increasing direction, we don't have any change. We don't have Reversing the direction has no effect, okay, unless you are changing the angle of inclination between the magnetic and the electric fields, okay. So it's only number one that has an effect on this. So the correct answer to question 30 is B. Let's go to 31. A wire is moved across a magnetic field. This causes an induced current in the wire. The induced current interacts with magnetic field to produce a force on the wire. In which direction is this force? A. In the direction of current. No, no. If a force, if look, a wire is moved across a magnetic field, this causes an induced current. The induced current interacts with the field and produces a force. Now, if a force is used to produce current in an electric field, and that current is now interacting with the field to produce another force, that the direction of that force will be in opposition to the force producing the current. That is how it works. The direction of that force will be in opposite direction. It will tend to interact, it will tend to oppose the force producing the current. That is how induced force interacts with the original force creating the current. So in which direction is this force? A. In the direction of the current, in the direction of movement of the wire, in opposite direction to the current, in opposite direction to the movement of the wire, in opposite direction to the movement of the wire. Why? Because it wants to oppose the movement of the wire. That's why it acts in opposite direction to the movement of the wire. Number 32. A 100% efficient step-down transformer has primary voltage Vp and primary current Ip, which role compares the secondary voltage Vp and secondary current Ip? A. Since a step down transformer, then it's time to bring down the voltage, okay? That means the voltage in the secondary section will be lower than voltage in the primary section, okay? That automatically means the current in the secondary section will be greater than the current in the primary section. So let's see, secondary voltage greater than primary voltage? No, no. Less than primary voltage? Less than primary voltage. So one of these two is correct. Let's look at the current. Current in the secondary section is greater than current in the primary section. That is correct, okay? Yes, so that means the correct answer to question 32, C. Yeah. You go to question 33. The scattering of alpha particles by a thin metal foil supports the nuclear model of an atom. Why are alpha particles used rather than neutrons? Because they always travel more slowly? No. Because they are heavier? No. Neutrons are also heavy, but not because of their weight. Because they are larger in diameter? No, not the diameter. Because they have positive charge? Yes, because they have a positive charge. Why? Because alpha particle is a helium nuclide 2 plus. So it has positive charge and it will be able to interact with the nucleus of the atom in which you bombarded the alpha particle. Okay. Actually, this experiment was conducted by Rutherford when Rutherford bombarded them gold foil with alpha particles. So if you look at that experiment, he was able to detect that the nucleus of an atom is heavy, is massive. So if you look at this experiment, you try to go through it. You can watch videos on it whenever you are free. It explains in detail the experiment that was conducted by Ernest Rutherford when he bombarded the gold foil with helium nuclei, and he noticed that some helium nuclei, okay, that's alpha particles are helium nuclei. Some alpha particles bounce back, okay, due to repulsion between the positively charged alpha particle and the positive nucleus of the of gold. Okay, good. So because they have positive charge, that's the correct answer to question 33. Question 34. An ion nuclide is represented by the symbol Fe2656. Which statements about the nucleus of the nuclide are correct? Do not forget that this 56 is the mass number. Mass number is 56, and this 26 is atomic number. Okay, atomic number is number of proton. So that means number of proton is 26. And do not forget that the mass number is number of proton plus number of neutron. Since the mass number is 56, the number of proton is 26. How do you get the number of neutron? Okay, mass number is 56, number of proton is 26. The number of neutron we do not know. Move this to the other side. Okay, so that means the number of neutron will be 56 minus 26. That means the number of neutron will be 30. Now look at this statement. Which statement about the nucleus of this ion nuclide are correct? The nucleus contains 56 neutrons. No, 56 is the mass number. The number of neutrons is 30, not 56. The nucleon number is 36. Is that correct? Is that correct? Can you say the nucleon number is 36? No. Why? Sorry, nucleon number is 30. No. Why? Because the nucleon number refers to what? It refers to the mass number of the element. Number 3, the proton number is 26. Of course, proton number is the atomic number of element. That is correct. So only 3 is correct, which is D. Number 34 is D. That's correct. Answer 34 is D. Number 35. A sample of a radioactive isotope has an initial rate of emission of 128 counts per minute and a half-life of 4 days. How long will it take for the rate of emission to fall to 32 counts per minute? Initially, the count rate was 128 counts per minute. And do not forget that its half-life is 4 days. That means after 4 days, what will be the count per minute? Initially, the count per minute is 128. But after 4 days, what happens? The half-life takes effect. So you have 128 divided by 2. That's what half-life does. 128 divided by 2 gives us 64. That's what will be left, okay? That is after 4 days. Let me use color red to represent the number of days, okay? So after 4 days, we have 68 left. Now let the second half-life take effect. The second half-life, we divide by 2 again, we have 32 left, okay? The second half-life, that means half-life is 4 days. After another 4 days, 32 will be left. Now the question says, how long will it take for the rate of emission to be 32? So for this rate of emission to be 32, it took 4 plus 4 days. That is 8 days. It took a total of 8 days for the rate of emission to fall to 32 counts per minute. That means C is the correct answer to question 35. 36. Several scientists are working in a laboratory. The scientists are experimenting with sources which emit ionizing radiation. Each scientist is given a list of safety rules. 3 of the rules are shown. Number 1, keep at least 2 meters away from other people. Do not stay longer than 4 hours per day in the laboratory. Stay behind the lead-lined screen. Which safety rules are for protection against the effects of ionizing radiation? Where do you have ionizing radiation? Stay behind the lead-lined screen. Yes, because they want the lead to protect you from the ionizing radiation. Also, do not stay longer than 4 hours per day in the laboratory. Yes, because it's in the laboratory that we have the radioactive materials. Okay, then keep at least 2 meters away from other people. Of course, this must not be in order to keep you from ionizing radiation, because the people are not emitting the radiation. It is the radioactive materials that are emitting the radiation. Okay, so this is the one that is not meant to keep you, that is not meant, okay? Which safety rule are for protection? Okay, this is the only one that is not for protection against radioactive radiation. The other 2 are meant to protect you from ionizing radiation. So 2 and 3, option D, 2 and 3 only. Question 37. Which data is needed to calculate the average orbital speed of satellite around the planet? Okay, how do you get speed? Speed, you divide the total distance by total time. And how do you get distance? You can get the distance since it orbits in elliptical cycles. Okay, if you want to estimate that, if you want to approximate that with the area of a circle, you can just use 2 pi r, okay, or you use pi d for that, for the distance, divided by the time taken. Okay, that's how you can calculate, you can estimate the speed of the satellite around the planet. Okay, now look at the option given to you. Option A, distance of the satellite from the planet. Yes, if you get the distance is the radius, we can use that. Radius of the planet. We don't need the radius of the planet. This r means the distance between the planet and the satellite. Okay, let this be the satellite. So r will be the distance between the planet and the satellite. Okay, this is the planet and this one here is the satellite. So the radius does not matter, it's just the distance. The period of rotation of the planet. And let's see what we have here. Let me just erase this so we can see this clearly. And the last one here is what? Is the time taken for the satellite to orbit the planet at once. Yes, we need that time. That's the denominator here. So we need the time, we need the distance. We don't need the radius of the planet. And we don't need the period of rotation. Period of rotation just talk about number of cycles that we completed in a second. Well, we don't need that. No, we don't need that. So to get the speed, we just need the distance and the time. So the distance and the time. Which column is that? Distance and time. 1, 2. That's option B. Option B is the one that talks about distance and time. So we shade option B for that question. So we shade option B for question 37. Let's go straight to question 38. So approximately how long does it take for the moon to how long does it take for the moon to make one complete orbit of the earth? Of course, that is 1 month, okay? 1 month, approximately 28 days. Number 29. The energy generated in stable stars comes from nuclear reaction. Which type of reaction occurs in the sun? Of course, in the sun, it is as a result of the fusion of hydrogen to form helium. Okay, fusion of hydrogen to form helium nuclide. That is what takes place in the sun. So hydrogen nuclide join together to form helium nuclide. That's option D. Correct. Helium nuclide break up. No. Helium nuclide join together. No. Hydrogen nuclide break up. Hydrogen, of course. Why would hydrogen break up to form helium? Number 40. Two quantities define the Hubble constant. This is space physics. The speed at which the galaxy is moving away from the Earth, which is v, the distance of the galaxy from the Earth, which is d. What is the relationship between v and d, and what is the current estimate of Hubble's constant? Now, take note that Hubble's constant is the ratio of the speed of a particular planet to the distance. What does that mean? It means yeah, it means Hubble distance is speed divided by distance of a planet. Okay. Now the question says, what is the relationship between V and D? You know that simply means V is equal to Hubble's constant multiplied by distance. Okay. From that we can simply say that what V is proportional to D. Yes, V is directly proportional to D. That means that the speed in which at which a planet is moving away from our solar system, as the speed at which a planet is moving away from the Earth is increasing, then as the distance is increasing, then the speed is also increasing. Yes. So all the planets, they are moving, but as the distance of separation between a planet and our solar system is increasing, then the speed is which is moving away is also increasing. Okay, so that's direct proportionality. Then current estimates of Hubble's constant. What's the current estimate of Hubble's constant? That will be this value, 2.2 times 10 to the power minus 8, minus 18 per second. Yes, this is the correct value. This is speed of light, of course not. This is the correct value, of course not speed of light. So that makes it the only correct answer. Okay, so from this relationship, we can see that from here, we can see that the speed is proportional to the distance. Yeah, okay, because Hubble's constant is the constant of proportionality, and also Hubble constant can definitely not be speed of light. Yeah, and that makes this the correct answer, the correct estimate of Hubble's constant. So this brings us to the end of your 2023 IGCSE paper 2, the extended question paper. Thank you very much for listening. Come back to watch more videos. Do subscribe to this YouTube channel. Do have a nice day. Goodbye.